So this week we are still going to be doing surface area and volume, but we are going to be doing surface area and volume with composite figures, and then later on we'll get to similar figures. Right, so composite figures is either going to be shapes put together, and you see you'll have multiple shapes put together, kind of like this picture over here. We have a cone on each side and a cylinder in the middle. Okay, this will also include shapes that are cut. Alright, so like we see, this used to be a cylinder, but it has been cut in half. Okay. So those are the type of shapes that we'll be working with on the first part of this week's notes. Alright, so for numbers 1 through 4, we're going to calculate the volume of each figure. And if you haven't already, there are blank notes on the Google form as well as on Schoology that you are more than welcome to print out if you don't want to draw these figures. If you are just taking on paper, go ahead and pause whenever you need to be able to copy the picture down. Okay. So when we're calculating the volume is usually the easiest to work with composite figures. So this is half of a cylinder. So we're doing the cylinder, our volume formula would be pi r squared times our height. Okay, but since we want half, we're going to do half of that. So we're going to find the entire cylinder and then divide it by 2. So we're going to do pi, our radius is right here, it's 8 feet. So we have 8 squared times the height, which is 6. Remember, the height is the distance from this. Looks like the height of the object is 8 because it's on its side, but it's going to be the distance from this circle to that circle on the back of the shape. And then we'll divide that by 2. And so we have pi times 384 all divided by 2. So we have 8 squared times 6, which gives us 1206.4 divided by 2. And then we'll take that, divide that by 2, and we get 603.2 in its volume, so that's going to be feet cubed. Now, something to note is if you use the pi button on your calculator, right, it's going to be different than using 3.14. Right, so sometimes I think you'll have been going through and working on some of the problems and your answer would be really close, right, maybe like 1 digit off or something. So if that's the case, if you used pi, go back and try just using 3.14 or vice versa and see if that gets you the right answer. Most of the time you should just be able to press the pi button, and it should match your answers that you're given are actually found using 3.14. So if you use these, right, you're going to get a different answer for each one. It's going to be relatively close. It's like if we used 3.14 here, we would end up with 602.9, right, which is very close to this. If you're that close, I would check how much of a difference it makes alternating between those. Alright, so for this one, right, we want to find the volume. Well, we have 2 cones, and we have 1 cylinder that's put together. Okay, so we're going to find the volume of each cone, right, and then we're going to add the cylinder. So we'll call this one cone 1, and this one cone 2. Remember, the volume of a cone should be 1/3 pi r squared h. So when we look for cone 1, we're going to have 1/3 pi. Our radius is 2. We can see that over here, and it's going to be the same because this is a cylinder, right? So the radius for all of these have to be the same. So we have 2 squared, right? And then times the height of the cone, which is going to be 6. So we have 1/2 pi times 24, which gives us 37.7. Alright, for cone 2, we're going to do the same thing, right, but we're going to have a different height over here. Oh, actually I need to go back and check this because that's supposed to be a 1/3. So let's try that again. 1/3 times pi times 24. We get 25.1. Alright, so down here we have 2 squared times our height, and on this one our height is 7. So we have 1/3 pi times 28, which gives us 29.3. So we have both of our cones. The last thing that we need is the volume of a cylinder, right, which we just used in the last problem, but it's pi r squared h. So we're going to do pi, our radius is still 2, right, and our height is the distance from this part of the cylinder to that part of the cylinder, so it's going to be 14. We're going to pi times 56, which is about 175.9. So the volume of the whole thing is going to be 25.1 plus 29.3 plus 175.9. Which gives us 230.3, and again it's volume, so it's going to be meters cubed. Alright, so what I want you to do now is for 3 and 4, I want you to go ahead and pause, okay, and I want you to try these on your own. Alright, so after doing those, for number 3, you should have gotten 280 meters cubed, right? Because we have our triangular prism plus the rectangular prism, so you end up with 120 plus 160. Over here you should have ended up with 211,697.9 meters cubed. You have your rectangular prism that's here on the bottom, right, plus half of this cylinder that's on the top. Okay, now the tricky part with this is figuring out that the length of this side here, right, is 66. And how you know that is because here it tells us that the radius of this cylinder is 33. So if the distance from here to that edge is 33, then that means the distance from here to this edge is 33, making the entire thing 66. Right? Then you go through and follow your formulas and you end up with your answer. Okay. So next we have our surface area. So here we're going to calculate the surface area of one of these. Okay. Now it tells us that this cylinder has a height of 18. And then this hemisphere, which is half of our sphere, has a radius of 5. So, when we're doing volume, we can always just take the volumes of everything and just completely put them together. Right? But when we're doing surface area, we have to look at things a little bit differently. Because when we take this cylinder and we put that hemisphere on top, okay, now we have taken the top of that cylinder and we've completely covered it up, and then the flat side of our hemisphere we've also completely covered that up, so we're no longer going to include those in our surface area. So we're going to need the surface area of our cylinder minus one circle, and then surface area of a hemisphere minus one circle. So let's start with surface area of our cylinder. So we'll do the cylinder down here. Okay, so our surface area formula for that is 2 pi r squared plus 2 pi RH. So we have 2 pi, and then our radius is 5. 2 pi, our radius is 5, and our height is 18. So 2 pi times 5 squared plus 2 pi 5 times 18. So that gives us about 722.6. Then we want to take away one circle. So we're going to subtract one of the pi r squareds away. We're going to be taking away about 78.5. So we have 722.6 minus 8.5. Which gives us 644.1. Right, so this is going to be the surface area of this cylinder, right? Because we have everything that's going around it. There's going to be a floor. Right, but we're not going to have anything on the top, which is why we took away this one circle. What some people like to do, and if that's perfectly fine, This 2 pi r squared is the part of the formula that's talking about the bottom and the top of your cylinder. So if you know that we're not including the top, from the beginning you can just change this to 1, right? And then you don't have to worry about this subtraction right here. Alright. Over here we'll do our work for the hemisphere. Okay, so that's going to be the surface area of a sphere. Right? And then we're going to divide it in half. And we don't have to worry about that because we don't include that in our formula anyway. So the surface area for a sphere is 4 pi r squared, but we have half of it, so we're going to divide that by 2. So we have 4 times pi times 5 squared all over 2. We did get us on 57.1, just about. So then to find the surface area of the entire thing, we're going to add those together. So then we end up with 801.2 feet, and it's squared because we're talking about area. Alright, this last one, go ahead and pause. Okay, so your final answer for this one, you should have ended up with 103.66 centimeters squared. We're going to add our surface area of our hemisphere, so we'll follow the same thing we did there. Okay. And then we're the surface area of a cone, right? So of this cone, and then take away the circle, right? Because we're not going to include that circle that we usually see on a cone. So the cone formula is pi r squared plus pi rl. So we have 3 as our radius, and then we have to figure out L, which remember is this distance here. If you look at this, it gives you this information, which is actually a right triangle. It's 3 and 4. So you can use your Pythagorean theorem, or notice that's a 3, 4, 5. So L is going to be 5. So we get 75.4, and then we're going to take away the area of a circle. So we find the area of this circle here, and subtract it out. Now, something you could have noticed is if we're taking away the circle, we're actually taking this part of our formula out. So really all you would need is just this pi rl, and that would have gotten you your final answer there. So once you get these two, you're going to add them together and you end up with 103.6 in its area, so it's going to be centimeters squared. Okay. So that is all you need for composite figures. Okay. Next we're going to learn incongruent solids, and we're not going to do all of these. Okay, we will do a couple, and then the rest you can try on your own, and I'll put the answer key on Schoology. Okay. So for similar congruent solids, right, this is going to follow similar to what we did when we had similar incongruent figures. Okay. So solids that have the exact same shape but not necessarily the same size, those are going to be similar solids. Solids that have the exact same shape and exact same size are going to be congruent. And then when we take the ratio of the measures, so taking the measurements of one solid and comparing them to the measurements of the other, that is going to be our scale factor, just like we did with similar figures. Okay. So whenever we have figures that are similar and their scale factor is A to B, if we compare their perimeters, it's also going to be A to B. and this is the same thing with circumference. And we know that from our similar figures unit. But if the scale to b, then the ratio of the areas is going to be a squared to b squared. And so when we're looking at figures, that's how things are going to match. Okay, so just like we did when we talked about our figures, right? If we're looking at solids, right, and the two solids have a scale factor of a to b, then their areas, okay, will also be a squared to b squared. Okay, and then the ratio of their volumes is going to be a cubed to b cubed. Right, and the easiest way to remember that is whenever we talk about perimeter, we always just talk about normal units, right? So our units stay the same. For area, we always do units squared, so we're always going to take ours and we're going to square it to get our areas. In volume is always units cubed, so whenever we're doing something with volume, we'll take our regular scale factor and we will cube it. So, for this example, if we were going to find the ratio of the parameters and the ratio of the areas, okay, well, first thing we're going to do is find our scale factor, which is always a to b. So it's going to be 4 to 6, which we can simplify as 2 to 3. Okay, well, the ratio of the perimeters, since these are similar, it's always going to match a to b, but just to prove it, the perimeter of this is 16 and the perimeter of this one is 24. So if we compared that, 16 over 24 is also 2/3. Right? So these should always be the same. Our ratio of areas is going to be our scale factor squared. Now, just to show that, the area of this one would be 16 and the area of this one would be 36, and if you compared those, that would be 4 over 9. Now, if you did this squared, 2 squared is 4, 3 squared is 9. Okay? So you don't actually have to find the area or the perimeters of each object. If you know one of these, you can work either forwards or backwards to find the missing part. If we're looking at example 2, we want to find the scale factor and circumference ratio, two similar circles with areas of 128 pi and 18 pi. So we know that the area is 128 pi over 18 pi, which we can actually simplify to 64 over 9. Remember, our areas are always a squared to b squared. And our scale factor is a to b. So to start here and move that way, we're going to take the square root. Well, the square root of 64 is 8. The square root of 9 is 3. So our scale factor is going to be 8/3. And then remember, these are always the same. So this will also be 8/3. Number 3, I'm going to find the scale factor of two similar triangles with areas of 10 feet and 60 feet. So go ahead and pause the video and try and do this one on your own. So your area factor should be 1 over 36. Remember, that's a squared to b squared. So to find your scale factor, you're just going to take the square root. You should get 1/6. Alright, number 4, the area of a smaller triangle below is 50 centimeters. Right, and we want to be able to solve for x and y. So that these are similar. Alright, first thing we would do, need to have one of these, and the easiest thing to do is find the area ratio. Right, because we know the area of this one and we know how to find the area of this. So it's going to be 1/2 our base times our height, which is 200. So our area ratio is going to be 50 over 200, which is also 1/4. Which means our scale factor, remember to get from your area to your scale factor you take the square root. So this is going to be 1/2. The square root of 1 is 1, square root of 4 is 2. So I know that x over this has to equal 1/2. Well, the only thing that x can be to make this equal 1/2 means that x has to be 5. And then same thing for y. Y over 40 has to equal 1/2, which means that y has to be 20. Number 5, the areas of two similar rectangles are 16 inches squared and 36 inches squared. The longer side of the smaller rectangle is 16 inches long. What is the length of the longer side in the larger rectangle? So we have two rectangles and we know that this one, the area is 16, right? And this one, the area is 36. And then it tells us that this side equals 16. No. So in order to figure out what this side is, we're going to need a scale factor. So we're going to start here with our area. We know that it's 16 over 36, which if we simplify is 4 over 9. So to get our scale factor, we will square root. And get 2/3. So that means anytime we compare one of these sides to one of these sides, it has to simplify to 2/3. So 16 over this equals 2/3, right? Which to get from here to there, you would multiply by 8. So multiply by 8 here, right? And we will get that this is 24 inches. This is actually going to be our last example. Okay, we're just going to complete the table for similar solids. So remember, anytime we have a scale factor, it's a to b. They're going to be a squared to b squared, and volumes are going to be a cubed to b cubed. If you know the scale factor, it's very easy to work your way. This way we're going to square everything, so we would end up with 1 to 9. And here we're going to cube this. 1 cubed is 1, and 3 cubed is 27. So 5 squared is 25, 2 squared is 4. And here 5 squared is 125. Sorry, 5 cubed is 125, and 2 cubed is 8. here we're going to have to work this way, right? But before we can do that, we have to reduce it. So this reduces to 4/9. So then we can take the square root and end up with 2/3, which then allows here over there. So we can cube it. 2 cubed is 8. 3 cubed is 27. Right. Lastly, if we have the volumes, we're going to have to work all the way back to our scale factor. So the first thing I would do is simplify and get 125 over 64. And then we're going to take the cube root of those. And you end up with 5 over 4. And then to move this way, you square it, so you end up 5. 16. Okay. 4, 7, 8, and 9. Okay, they're going to follow the same pattern. This time they're just using the volume ratio. Right, so you're going to be working with cubes, right? And you might have to take the cube root to get back to your scale factor. Right, so you can go ahead and try those on your own. The answer key will be posted on Schoology. Right, after you finish your notes, move on to the practice section. Right, so you either have a practice worksheet or you have IXLs that you can work through. Make sure to take a picture of it, whatever practice that you work on, so that you have some evidence, because there'll be a Google form that you fill out at the end of the week, right, providing evidence that you worked on practice, right, and then you'll have your weekly quiz. If you have any questions, make sure to join our office hours. Holmes' office hours are on Wednesdays, and Baker's office hours are on Fridays. Thank you, and have a good week.